And with that, we'll move to the next presenter, Sean Hehir of BrainChip. He's got a very extensive background in the electronics semiconductor space, including stints at Compaq, HP. Here to talk about BrainChip today. Please welcome Sean Hehir.
So, often you go to a conference and you have to follow something and say, I don't know, it didn't do a good job setting me up. Kevin did a great job of setting me up. So what I'm going to talk about today is that sixth wave that he talked about in the second slide or the third slide. And also maybe I'd like to modify, I think your fourth slide when you had the ecosystem, there's a little IP block. BrainChip needs to be up in there. So we'll put that up. But what we do, just to set the context when I talk about AI in a moment, we're an IP provider for what we call an NPU, a neural processing unit. And all that is when you talk about AI, he just talked about semiconductor. And when you think about semiconductor and kind of CPUs running applications and operating systems, NPUs excel at running models, AI models. So that's what we do. So let's talk a little bit about the industry here. So what's going on with AI? How do you simplify a very complex space in one or two slides? Like he tried to simplify a complex industry in a few slides. But there's some tremendous driving forces in AI going on right now. One is pervasive adoption across all industries. There is not an industry in the world that is not being affected by AI. You pick it, I'll give you an example. All right, so it's just affecting everything. And if you think about the waves that he showed on his second slide, they're all about productivity, enhancing lifestyles, greater efficiency. AI is the next revolution that's changing the world. It'll make the industrial and, quite frankly, the information wave look like nothing. And it's early. So it's very pervasive across all industries. What's driving it is usually the use case, right? And you see silicon at the bottom, but it's always the use case. And when I talk about the rapid model evolutions, I've been the CEO of this company about 3 years. We are now required to support model types or categories that didn't even exist 2 years ago. That's the pace of innovation that's going on in AI. Model change is coming incredibly rapidly. And what's driving all that is demand for higher business value. Models drive the business value. The third major trend going on in the industry right now is the demand for more human interface, or NLP, natural language processing. It wasn't that long ago. All interface with AI was through a keyboard. Not anymore. And it's crossing, again, all industries and all use cases where people want to talk to the devices and have very intuitive interfaces. And all those require certain silicon requirements. And then the importance of inference. Kevin showed a slide about the size of NVIDIA, and those who follow NVIDIA closely know that they are primarily used for a big training kind of system. With AI models, you train them, then you deploy it for the inference, and inference is where the magic happens. That's where things are going, and you can actually get some business value. And many analysts, financial analysts, say the next 10 to 20 years, all the investment's going to go towards inference. The training market is kind of stable. It is what it is. But inference is where it is. And so a company like us, we focus on inference. And like a lot of companies, we're focused on where the value is for the customers. And all of that is underlining with silicon. You can't do any of this without the right chip. And I'll talk a little bit more what that means. There's another major trend going on. Like all compute models that start, those of us that are around that will be dead when quantum comes to maturation, I'll be joining you. They all start in a very centralized model, right? It's just the way life is. We start very centralized. And you realize that one size does not fit all for every kind of business problem. And eventually workloads distribute outside of data centers to a decentralized model. So you've got this thing called edge AI. I mean, most people think of things like ChatGPT and others, big data center, but the movement in the market is all towards the edge. Basically, it's the right tool for the right job. That's what you want to have. And there's a whole industry developing around supporting that, whether it's certain model development, silicon development, and things like that. And each one of these business models or deployment models have some pros and cons. So in the data center, they're ideal for training, right? Because it's very power intensive and things like that. It's certainly driven by a lot of the Gen AI stuff. The training that goes on is just so extensive. We spend a lot of money in our company training models inside of data centers, but they come with some downsides. You've got tremendous energy costs associated with that, and you've got large infrastructure costs. So that's the downside. The edge, ideal for inference, and that's exactly where we are right there. No need to bring it back to the data center, introduce latency, security concerns, things like that. The edge is ideal for inference. And there's a very cost-efficient benefit to doing it at the edge. Sometimes it's just avoiding the cost of a connection that people are trying to avoid, because that drives costs as well. But you have limitations. When you're working with small pieces of silicon, you're going to have to work with smaller models. And so what you see going on in the industry is models getting smaller, more refined, and the silicon gets smaller, more refined, still driving more business value, almost like Moore's Law that you described. People want more value, but they want it on smaller silicon on smaller models. And the industry is delivering all that right now. And then, of course, those that are engineers in the room or people that are aware of how this industry works, it's all driven by engineers. And when you've got newer technologies, the engineers are required to know new tool chains. So it's important, even though we're a hardware provider, we spend a fair amount of energy and a fair amount of capital to make the best tool chain. You want to make it super easy for your customers to deploy your technology, super easy to move models onto your technology. You cannot underlook the software stack. I was recently talking to a prospect CEO. He goes, "Hey, I got a question for you. When I talk to companies like you either fall into one category or the other. You got great hardware and bad software, or great software and bad hardware. What are you?" And of course, I said, "We're great at both." And he goes, I don't believe you, but that's how the industry looks. We want to excel in both of those dimensions, and we do. So since we're at a capital markets type of meeting, a little bit about our view of size of the edge market and what it can be. And it's consistent with what Kevin showed as well. I mean, what you see is rather large markets, certainly large markets for the silicon opportunity, and very large growth rates associated with it. And it's still early. I keep stressing to people right now, it's early. The growth and the demand is accelerating. One of the great privileges I have in my job is to talk to prospects and customers on every single day. And I'm constantly amazed with the innovative use cases that I hear. One of our sales guys say, "Hey, can you talk to so-and-so?" And I'm like, "What are they doing?" And I'm like, "Interesting idea." So it's very, very early in the use cases. And I'll show you a couple use cases here in a moment. So, we're at a semiconductor conference, and I think it's important to understand that you can run models like you run applications on anything. It doesn't mean it's a smart thing to do. Just because you can do it, you shouldn't do it, right? And so you can run models on a CPU. Of course you could, but it's grossly inefficient. And what you're trying to do is get over to that left side, and it says ASIC. It could be an SoC or other kind of purpose-built hardware. And so companies like us at BrainChip, what we do is try to get the ideal crossroads between the power requirements for an edge device, because it's always power sensitive on edge, the smallest piece of silicon, because it's going to go in a device that's on your wrist or in your ear, on your face or something like that, and of course the highest level of performance. So our typical engagements, we go down and say, what are you building? How are you building it? What do you need to get out of it? And you trade off on all three of those vectors, and you get the absolute optimal piece of hardware to drive your use case. So a little bit about the company here, so to help position and what we do and how. So when you're an IP provider, it's important to be versatile, right? And so we have our structure, we have a scalable piece of IP. You can scale it very, very small, less than a single node, or up to 256 nodes, depending on how big, what your compute is, the size of your models, et cetera. It's fully digital for those that are familiar with the industry. People think of us as, or think of a lot of technologies being analog in the space because we're neuromorphic, and I can describe that a little bit longer, but we're fully digital. So a lot of those fabs that Kevin was showing earlier, it's fully portable. You can just bring it over and work just fine in there, which is very important because we want to address all the use cases in the market. I mentioned the software stack. I think it's so important. We have a software stack, and a typical normal engagement goes like this. A customer comes in and says, I want to do this, and I've got this model. How do I put it on there? So we actually have a software stack where people can bring their models in. They can performance it and say, oh, I'm going to get this kind of frames per second, this kind of latency, whatever the attributes you're looking for, and said, okay, we'll design our software or our models this way, and we'll do it for our chip. And then it's really important as well to have an extensive model zoo. In industry, again, right now, some people have their own models and others want us to have models. So our company has a whole set of machine learning experts that are creating models. And our model zoo is growing every single month. We add more and more models, refined models, different types of models for different use cases. So that's how you get into this space. You have to offer the full solution. You can't just be a hardware provider. We showed this slide yesterday, and I'm not going to turn this into a BrainChip commercial, but the reason I show this now, this is our roadmap that we told the public yesterday. We're actually our current generations are generation 1 and 2. We'll have our what we call our generative AI offering out to the market pretty soon. I made a commitment that we'll have it before our next AGM. We'll have it before then, and then we're going through a third generation. I only show it to this group for a couple of reasons. Is one, I mentioned earlier the pace of change in this industry. We are never going to, there'll be a 5 and a 6 and et cetera, just like every other company shown on the earlier presentation. You've got to constantly innovate to stay ahead in this industry. Every customer, literally every single one that I talk to says, I want to see your roadmap before I make a decision. It's your technology today is important, but your technology tomorrow and 2 years from now is very important for me. And we do have vision past this that we don't go to, but it's always important in this space, as everybody in the silicon industry, to always have a view for the future because people are betting their business on your technology. You got to remember, if they're doing something like this, building a custom chip, they're trying to compete better in their markets, right? They're not just doing this when they could buy something more generic. They view competitiveness, and this is their differentiator. So they want to make sure there's a future because once you're in, you're going to stay in. So let me give you a couple of cool examples on the edge, the things right there. So this is a partner of ours right now that we work with in a drone. And this would not be possible in a data center. And what you see is a drone carrying one of our chips out over the ocean and a lifeguard probably sitting back, maybe drinking a Coke or some other beverage, looking at the beach, trying to understand who's walking, is there anybody in distress, and sending back a signal over a radio to say, yeah, everything looks cool. Couldn't do that. Now, what does that mean? Less lifeguards, more cost savings, more efficiency, right? More safety, win, win, win. But there's just a real life example of the things that when I first heard about this, I'm like, what a cool idea, right? That we get to participate in things like this. Now, my next one is my favorite one. I had the opportunity to visit Oman about 2 months ago. And it's really interesting, again, when you think about the globalness of this industry, Oman is really trying to go super aggressive into the semiconductor space, and specifically in the AI silicon space. I talked to many leaders in their government about this. They're deadly serious about this kind of investments that were outlined in the first presentation to make it happen. And this company here is a company that's working with us right now called OnSour. And they've taken one of our chips and they're putting it into these glasses, and they're going through clinical trials right now. They have very aggressive plans to roll it out around the world. Their frames are being developed by Luxottica, the same ones that do the Meta frames. And in this case, you put it on, and if you have if you're an epilepsy sufferer, it's predicting with 98% accuracy that you will have a seizure within 1 hour. And so if you're one of those people and and the stories are so interesting. I was at their launch party and I got to talk to a lot of people who have epilepsy, and they said, I was afraid to drive because I didn't know. Now I know, I get off the road. I was afraid to go on a trip. Now I can go. So it's truly life-saving. And this is what Edge AI can do, that kind of power, bring that. So it's all about advancing the technology for that. Yeah. Okay, sure. Thank you. Since it is a capital markets thing, I thought we'd talk about how companies like us make money, and every other company like us makes money. The typical IP provider sells licenses. So we talk to companies that are going to design their chips. They buy a license from us. As chips come off, they certainly have royalties that they pay us as a percentage of their ASP. And then, of course, there's usually some services that we provide to make that happen. And that's when you think about companies like us, how you should evaluate them for investment. So to bring it all to a close in my short period of time, to have a few minutes for questions, hopefully, is there's a big shift right now from the cloud to the edge. That's not going to change. I think you'd agree those kind of use cases I just showed were not possible. And there's many others that are like that. Dedicated hardware is always going to be better. That's what drives this kind of space. General purpose hardware will not work in the AI space. And all the trends and silicon models are all converging to more efficient kind of compute models. And I believe the following. It's interesting about this market. When you talk about the data center, it's very clear there's leaders in there. There's two or three, or there's one big leader, and there's a lot of kind of baby leaders in there. The edge market is fragmented. But like all markets, eventually leaders emerge. BrainChip right now is viewed as definitely a leader here, but there's still a lot of people in that market. My vision for this company is, as this industry consolidates, is to be that leader for this market for the next 20 years. I'm often asked, well, what's the goal for the company? Do you see this as something, somebody buying you? We think we have an opportunity to be an absolute leader in this market and with our products, and that's why we push so hard on our innovation. Thank you so much for your time.
Thank you, Sean. And let's open it for questions. Anyone in the room here? Right here.
Cool business. Very interesting. Thank you for that. Sean, a question and a comment. Question first is, can you give us an idea of what your challenges are in terms of your roadblocks, your potential risks, and maybe even talent as an issue?
Yeah. Well, let's take it in reverse order. Talent is everything, right? And we hire the best and the brightest. Now, we're lucky or fortunate that the kind of people we get, when we get the best, are out there to change the world. We're competing for talent against huge companies, and so we're in California. We have people all around the world, but I'm in California, so we're competing against Silicon Valley wages all the time. We're in Southern California, but people are driven when they see the possibilities of this, and also see the possibilities of the return when I talk about being a leader in the space. They have visions of trying to help a lot of people, and they also want to make some money on that. So talent is something we work very hard to get the very best and keep, because you can't do that kind of stuff without anything else. That's the big challenge. I forgot, what was the other part of your question? Yeah. Yeah, I mean, the risk for us is that we don't get our roadmap right. And so, we always look at it, again, without getting overly technical, is what is the trends in the models? Because you have to make sure you support the model trends. And I didn't go into this today, but I'm sure everybody's heard this generative AI or LLM kind of language. Most of them are what they call transformer type of models. However, leading companies are now recognizing a class of models called state space models. IBM came out last week and called it the best model type you never heard of. And during the Masters, if you're a golfer, they had a very simple ad: smaller can be better. And Tencent is making a big push on their NVIDIA towards what they call SSM, state space models. We have a huge lead on that right now. We have a proprietary algorithm called TENS, which is state space models. And before our AGM yesterday, our head of engineering talked about a particular use case where we were doing compute 64 times more efficient than a transformer. So that, if you think about the 64 times less compute, which means a much smaller piece of very expensive silicon at the same results. So yeah, understanding the model trends and staying ahead of it. So we have, like I say, a fair amount, even though we're a silicon company, a fair number of machine learning people and a world-class CTO to plan that for us. Question back there, Mark?
Hi, thanks. I just try to understand, like you talk about the data center and you have the edge. I'm trying to understand because I'm not a technical or computer people. So with the data that goes through into the data center and then it does it go to the edge computing chip like that? That's the relay? Is that right? Can you bypass the data center and the data and go directly into your devices?
Okay.
Because it's near term and you want to cut down the latency and all that.
Yeah. Really, the way to look at it at its simplest level, you don't need a data center. Like those two examples, they don't use a data center. They just don't. So all the inference is done and gives you the answer right there on the chip. So it's a very discrete form of computing. That's not to say you can do it the way you described. You can do some of the computing there and then some of the computing in the data center. And that's we have some customers that do that as well. But the most common use case is the ones like that where it's discrete because they don't have networks. You don't have networks walking around when you have glasses and you're out in the boat or something like that, right? Or you're flying that. So you want to be able to do the compute without any kind of network connectivity.
We've got time for one more. Yeah.
Talked a lot about large language models and maybe just sort of, and you gave us the example of the drones on the beach.
Yeah.
But maybe just a couple of examples of the verticals or the industries where you see the best or the most prospective applications of your tech.
Sure. I open with a statement that it's affecting all industries, but some are more aggressive than others for sure. In certain regions as well, by the way. We are seeing, certainly in the industrial space around IoT, just think about this technology, preventive maintenance and things like that. Very strong demand there for sure. Medical. We see a lot in medical and a lot in consumer electronics as well. Yeah. We believe, by the way, auto too, there's engagements going on there, but the adoption cycle is so long, right? If you think about the auto thing, a car is nothing but a rolling bunch of computers and sensors right now. And the ability to do compute without a network is important, but that's going to take some time. Yeah, it is. It is. It is.
All right.
All right.
Yeah, of course.
I think maybe you all might want to go look up Dr. Amy Webb. She's a futurist, really interesting speaker. You can see a lot of her talks, TED Talks, etc. Your example here of the predictive epileptic fit scenario, you'll see that referred to in her talk, but also you'll start to see some things that might be a little scary. If you are old enough to know the movie Blade Runner, there's a lot of research going on right now where we are predicting your behavior, my behavior, about whether or not you're going to commit a crime 3 minutes from now or 1 minute from now. So that has some very interesting permutations. And actually, we can predict behavior before you even know you're going to go do it. Very interesting. Amy Webb.
Yeah. Can I get one of those for my wife?
What's that?
That's the ultimate application, right? So hang on, one second.
If you apply for a visa for the United States on the electronic model, one of the questions is, do you intend to commit a crime in the United States?
My answer is not. My answer is not today.
All right, Sean. Thank you very much.
Thanks, everybody.